name's Dr. Stuart Morris. I'm the Engineering Director here at Pentaxia. Pentaxia was founded in 2008 as a composite tooling component composite manufacturer. We deal in the aerospace, automotive, space and motorsport sectors. We also do some defence work as well. We have a 70,000 square foot factory on a 7-acre site. So in our industry, sustainability is a key issue going forwards, especially within the aerospace sector that we work in. So we teamed up with the AMRC and then we approached NATEP for some funding to do a sustainable tooling system.
I'm Albert Gibbs, I'm the lead engineer on the EcoTool project. Next to me we've got two very different ways of curing carbon fibre components. At the back we've got a state-of-the-art autoclave, and here we've got the EcoTool, which represents a low power, low cost solution with limitless scale for curing carbon fibre parts. This is a direct heated tool. By electrically charging the carbon fibre that's in the tool, we've had minimal impact on the tooling laminate to create something that can still be heated, but also conforms to all the aerospace standards that are required.
I'm Oliver Simpson. I'm a development engineer at the AMRC, specialising in multifunctional composites. The main benefit of EcoTool is we can produce large-scale components at low power, reduced time, and therefore minimal cost. So this was taking a concept that was originally desktop-based, simple geometries, and scaling up to large-scale, complex geometries like the one behind me. The key challenge with that is temperature conformity. So to get temperature uniformity on a large-scale tool like this, we split it into separate zones, then created a control system to split the power into those zones, as well as some software to create a PID loop with the thermal output of the tool to match against a cure cycle. So not only can we do complex geometries, but we can also do complex layups. And so we can do a thick layup in one zone and a thin layup in another, and can tailor the power to suit those thicknesses.
This process requires a lot less energy than your traditional method of manufacturing carbon fibre parts, about 98% less energy, and that's because you don't need to put it in an autoclave. Because you don't need to put it in one, you also get away from the limitations of scale that you've got. We're running a 4-metre tool during this project, but there's really no reason you couldn't go to a 15-metre, 20-metre, as large as you like. There's no physical limits on the size of the parts you can make using this process.
So one of the benefits of using direct etch curing is the fact that you can cure the tool as well as subsequent parts of the tool, completely removing the need for the autoclave. So the best analogy I can use is if you're in your car and you turn on the heated seats versus turning on the aircon. The aircon has to heat up the whole car, whereas the heated seats heat you up directly, making it a lot more efficient.
We looked to NATEP funding to help us de-risk the innovation that we wanted to do. We knew we had the people, we knew we had the capabilities, but needed a little bit of help and support with the technical management and the funding, and prove to everyone that the components that you can make using this technology are as good as what you're going to get out of an autoclave.
This technology has come on a long way since we had the NATEP funding, joining with the AMRC to take this from a conceptual idea with some prior background through to where it is right now today. To go to the next level, I see ourselves partnering with a Tier 1 aerospace supplier and doing a lot more development work around sort of actually getting the technology refined down for the aerospace industry. Because the aerospace industry can't take many risks, so we need to make sure our project and the technology is really dialed in.
One of the nice things about NATEP is that you've got some really small companies, and the funding enables them to take these ideas from almost a germ into a fully realised prototype. And then their potential customers can see that they've actually got something to offer. So it really de-risks that process and enables them to take it to the next level. When these guys brought this project to us, it seemed to me, not being a composites expert, to be quite a simple thing. But once they got into the weeds of the project, and I started to realise the complexities of getting this large geometry right, then it made me appreciate much more what they're up against. I always knew that Pentaxia would do a good job on this, and they have. I didn't know that they would achieve 98% energy savings, but they have. The fact that this is the same form factor and the same curing process as the autoclave tooling means that certification should be a straightforward process. I certainly hope it will be, because this has the potential to be the new standard.